In the last video, we saw how to use truth tables to determine the truth value of a complex proposition given the different truth value combinations of the simple propositions that make them up. This video is going to be very much the same kind of a thing, only we're going to add an extra step here that's going to allow us to work with multiple propositions at the same time. It might seem a little bit repetitive, but then again, getting extra practice with this stuff wouldn't hurt. Now, there's only one example problem from the chapter. We'll do that one, and then we'll get into 3.4.1, the exercises, and then we'll get a little bit of practice on how to do this. Notice that the only thing different here from the last time is that we've added an extra proposition on the end, and that's it. That is the whole thing here. I don't know why we need an extra chapter for this, but that's what we're doing. So we have if P then Q, and then slap it on an extra one. It's not the case that both P and not P. Now, I'm not sure if you remember from the last time, but here's the strategy here. We're going to take that little empty box on the left there, and we're going to fill it with all the simple propositions that we have that make up the complex propositions on the right. So I have a P and a Q. Now, next step, we're going to fill out all the different possible truth value combinations for these two simple propositions. And we're going to use this as a key sort of to fill out the rest of the complex propositions to the right. The different possible combinations, if you don't remember, check out the last video. I talked all about how we could figure out what those are. There's going to be 4 here. P can be true and Q can be true. P can be true and Q can be false. And then I look at that Q could be true or false. Let's repeat that down here because P could be false at the same time that Q is true or false. So we have 4 different possible combinations of truth values for P and for Q. Now, next step, all we're gonna do is copy and paste the truth values from the simple propositions in our key to the left over to the simple propositions as they show up in the complex propositions to our right. There's P, and now we'll copy Q. Okay, so we filled out the different truth values for the simple propositions as they stand in the complex propositions. And notice we've just sort of transferred the T's and the F's across the line. So in the first row, P is true. So in both complex propositions where it says P, we put a T. And again, that's the only extra step that we're doing here. But of course, now we have to look at our rules and see how those truth values for the simple propositions determine the truth values for the complex propositions. This first complex proposition, P if P then Q, when I look at my if then rule, it says that this thing is true every single time except for when the antecedent is true and the consequent is false. That's that second row. That's the only time that that is going to be false. And there's the truth values for my first complex proposition. Now let's look at the second complex proposition. I see that P and not P, it's that not that I'm gonna have to do first, the not P I should say, that I'm gonna have to take care of first. I look at the truth table for not, and I see that all I have to do is flip these T's and F's. Okay, now I have the truth values for the 2 conjuncts that go into that inside conjunction. Now I got to figure out what the truth values are for the conjunction. So again, I check out my rules for conjunctions, and I see that anytime one of the conjuncts is false, the whole thing is false, and that's going to happen every single time here. There are at least one conjunct that is false. But finally, we have a negation of the conjunction. There's a negation of this whole thing. And every single time it's false, and I look at my truth table for a negation, and I see that every single time I'm going to have to switch that false to a true. So there we go. The truth values for our 2 complex propositions really wasn't that mind-blowing. Let's go ahead and move on to 4.4.1. We'll do number 1 here. For number 1, just for a little bit of practice, once again, I left off the key to the left here. So I'll throw all the different simple propositions that we're going to see in our complex propositions to the right. I'll throw them in the key over here. Let's see. P can be true, Q can be true, P can be true, Q can be false, P can be false, Q can be true, P could be false, Q could be false. Those are the only possible combinations we have. Now we're going to copy and paste. Here goes P. And now Q. So now I have 2 different complex propositions here that I'm going to have to determine the truth value for. These are actually going to be pretty easy. If P then Q and if Q then P, those are both conditionals. So I'm just going to have to look at the rules for conditionals. And I see, once again, the only time these are false is when the antecedent is true and the consequent is false. And that happens on row 2 for if P then Q. And row 3 for if Q then P. And there we go. We have all of our possible combinations of truth values for our two complex propositions here. For number 2, I've already filled out the key over there on the left, and for the rest of these, I'm just gonna go ahead and fill them out ahead of time. But I'll copy and paste the truth values from P and Q. Now that all of my simple propositions, all their truth values are all filled out, now let's take a look at these different complex propositions. Our first one is, it's not the case that if P then Q. Our second one is either P or Q, and not the case that both P and Q. In the first complex proposition, it looks like I'm gonna have to build up that conditional first. So again, I check my truth table, and it looks like the only time it's false is in row 2, because the antecedent is true, but the consequent is false. And now I have a negation of the conditional, so I'm just gonna flip the T's and the F's. And it looks like this complex proposition is only true when P is true and Q is false. Now let's check out the second one. It looks like I'm gonna have to build up that either or, that P or Q first, and also the P and Q. We'll build them up in the same step. Checking out my rules, the or is true whenever any of the disjuncts are true. It's only false when both disjuncts are false. And that only happens in row 4. Looking at my conjunction rule, it's only true when both conjuncts are true, and it's false every other time, so it's only true, it looks like, in row 1. Okay, now before I can move on and put those two into a conjunction, it looks like the second conjunct there has been negated. It's got a negation in front of it, so I'm gonna have to flip all those T's and F's. And finally, I could put these things into a conjunction. And remember, conjunction only true when both conjuncts are true. And it looks like that happens in rows 2 and 3. There you go. It looks like both propositions, both complex propositions are true only when P is true and Q is false. That's the only time both of them on both sides are true. All right, 3, a lot of the same thing. I'm going to copy and paste from P's and Q's. Now in the complex proposition on the left-hand side, looks like I'm gonna have to put the not Q first, so I'm gonna have to flip all those T's and F's. And now I'll build that conjunction on the inside, only true when both conjuncts are true. It looks like that only happens in row 2. And now it's time to negate that conjunction, so I'm gonna flip all the F's and T's. Now in our second complex proposition, again, that's a negation, so I just have to flip the F's and T's once again. And it looks like here, the only time that both these complex propositions are true are when P and Q are both false. Example 4 looks like we have 3 different propositions, 3 different simple propositions in here. So once again, we'll just copy and paste first. Now in that first complex proposition, it looks like I'm gonna have to build up that conditional first, that if P then Q. Now things are gonna get a little bit more hectic. Again, when I'm looking at conditionals and I'm filling them out, the only thing I'm really looking for, first I look for all the trues on the antecedent side, then I look for if any of those have a false on the consequent side. I fill those out with the F's first, and then everything else I know is a true, because that's the only time when it's false. Looks like the only time we have a T and an F is on rows 3 and 4, and then everything else will be true. Now in that first complex proposition, I can build up that conjunction, and remember, only true when both conjuncts are true. If either conjunct is false, then the whole thing is false. And that's the truth value of our first complex proposition. For the second complex proposition, looks like I'm gonna have to build up that inside disjunction first, Q or R. Remember, it's true whenever either disjunct is true, possibly both. The only time it's false is when both of them are false. And then we have P or Q or R. It looks like the only time that one is false is in the last row here. There you go. It looks like there's 3 places where both complex propositions are true. When P, Q, and R are true, when P is false and Q, R are true, or when P and Q are false but R is true. It looks like R has to be true. Problem number 5 is ugly. We have 4 different simple propositions in here. Because of that, we have 16 different possible combinations here. This is where using a computer is so much better because you don't have to do like on paper. It gets really ugly. And the copy and pasting is, you can imagine when writing it all down, it's just tedious. So just let me go ahead and copy and paste here. My next move here is almost always to hit the negations of simple propositions. So where you see that not R and the not S over there, I'm gonna go ahead and flip those T's and F's. The next thing I'm gonna have to worry about is building up those inside conjunctions for complex proposition number one, the P and Q, and then the not R and not S. And obviously things are getting really hard to keep track of. So I know the conjunction is true only when both conjuncts are true. I'm gonna go ahead and look for all the cases where both conjuncts are true and throw some T's in there, and then the rest of them are gonna be F's. And then finally, I have the big conjunction of the whole thing. And again, only true when both conjuncts are true. So let me go and hit those places. And it looks like the first conjunct is only true in the first four slots. So I'm not even gonna look at the rest of the slots. The rest of this is gonna be false. Now for complex proposition number two, it looks like I have to build up the conditional first. Again, I'm gonna look for a T and then see if there's any F's. Then it's gonna be false. Otherwise, I'm gonna put true. Next, I have to build that disjunction P or if R then Q. Again, only false when both disjuncts are false. So one nice thing here is that we have all the F's for the first disjunct are all bottom half of the screen. So I'm only going to check those. Finally, that whole big conjunction there. And I see there's a ton of truths on the left-hand side. So we got a lot of stuff to check. And there you go. It looks like the first proposition is only true when P is true, Q is true, R is false, and S is false. But on that case, the second proposition is false. So there's no case where you can have both of these complex propositions be true at the same time. That's kind of an interesting result. 6 is going to be a lot easier. Again, we'll copy and paste to start off. Then we'll hit those knots. And finally, we'll hit those conjunctions, but I can already tell you these are contradictory. So both of these are contradictory. So it should be always false, and sure looks like it. And another thing that's interesting to note about this is that we have two complex propositions. They don't actually share any simple propositions as components, right? They don't have the same ones in there. And yet we could still do this thing where we kind of put them next to each other and figure out, given the fact that P is true and Q is true, or P is false and Q is true, how do these two things relate to each other? All right, let's go to 7. And in the first complex proposition, I see I have to build up that biconditional first. Biconditional is super fun. They're true when both propositions that make them up are true, or both propositions that make them up are false. They're only false when one of those propositions is false and the other one is true. And then we can finally work on that disjunction P or Q if and only if R. Now for the second one, it looks like I have to build up that conditional first. Again, I'm going to look for any T's on the left and F's on the right. And finally, the conjunction, only true when both conjuncts are true. And now we see that these two complex propositions are both true only when P, Q, and R are true, or P and Q are true and R is false. So in other words, the truth value of R doesn't really matter in this one. Number 8, let's go ahead and copy and paste. For the complex proposition number 1, looks like I'm gonna have to build up that P and Q, that conjunction first. Again, true when only when both conjuncts are true. The next step is the bigger conjunction, P and Q and R. And then finally, negating the whole thing, just flipping the F's and the T's. For the proposition on our right, number 2, it looks like we're going to have to deal with both of those conditionals and then get into the biconditional. So again, we're looking for a T on the left, an F on the right, a T in the antecedent, an F in the consequent. And for the biconditional, it's true anytime both propositions are true or both propositions are false. It's only false when one of them is false and the other one is true. There we go. It looks like we have a lot of overlap at the bottom there. In the bottom 5 rows, both complex propositions are true. Let's do 9 now. Now we have 3 complex propositions all lined up, but yeah, not that mind-blowing. We're going to look at the disjunction first here. Complex proposition number 2, the negation causes me to just flip the F's and T's. And then disjunction, only true when both of these guys are true, which happens actually in 2 spots. So all 3 propositions are true only when P is false and Q is true. Finally, number 10, again, one of those heinous ones. So a lot of copy and pasting. Actually, I shouldn't say a lot of copy and pasting, not much copy and pasting. It's a lot of writing if you don't copy and paste. Let me do proposition number 2 first. That's just going to be easier. That is the not S, and we're just flipping F's and T's. Now, complex proposition number 1, looks like I'm going to have to do that first conditional in the inside, if R then S. Next conditional, if Q then, if R then S. And then finally, the whole big conditional, if P then, if Q then, if R then S. And that's it. I'm sure there's some kind of cool relationship here, but I'm not going to explore it because that is way too ugly. For next time, go ahead and read 3.5 and do 3.5.1 exercises.